We have already defined the OC function as well as ASM function in the case of sequential testing. Now it's time to study the OC function of the SPRT, that means the sequential probability ratio test OC function. Of course the characteristic or the meaning doesn't change too much as far as the SPRT and uh, sequential testing is concerned, but since it's a simple hypothesis against simple alternative and we know the values of A and B, this OC function is elaborated more as compared to the OC function in the case of sequential testing. Now we know that SPRT is a test for simple hypothesis theta naught against theta 1. However, it may be that the true value of theta is neither theta naught and theta 1. That is also possible. Hence, it is of interest to study the nature of OC function. Please remember that OC function gives us the accuracy. So, therefore, it is of interest to study the nature of OC function. That is nothing but L of theta of the test over the whole parametric space. Let us state a lemma regarding the property of MGF, which we are going to use in the in this particular proof also. That property of MGF is that let Z be a MGF means moment generating function. Let Z be a random variable with a distribution function f. Then these are the four things. One is phi t will be equal to expectation of e to the power tz exists for all t. Let probability that z is greater than equal to 0, such a probability is greater than 0, then we have the following results. Strictly greater than 0 है तो ये following result denoted by a and b are true. One is that expectation of absolute value of z to the power k is less than equal to infinity for all k. Then equation phi of t equal to 1, if this is the case, then it has only real root t equal to 0 if expectation of z is equal to 0, and if t is not equal to 0 if expectation of z is not equal to 0. So that is the case if phi of t equal to 1. So we are going to use actually reverse this. We are going to get this situation, and therefore we are going to assume that phi of t is equal to 1 during the proof. So let us consider the problem of determining OC function, that is L of theta, taking z is equal to, we know that z as far as SPRT is concerned is nothing but log of f theta 1 x upon f theta naught x, where f theta is a PDF of continuous random variable x. Now by definition we have phi of t, which is equal to expectation of e to the power t z will be equal to expectation of e to the power z whole to the power t, right? So that can be written by using the definition like this. Let us denote this phi of t by equation 1. Now it is assumed that expectation of z is equal to expectation of this log of this. Instead of z I have put its value is not equal to 0. So if it is not equal to 0, then the condition of lemma are satisfied, and it follows that phi of t will be equal to 1. जो मैंने फोर्थ b प्रॉपर्टी बताया था उसका रिवर्स अभी हम लोग यूज़ कर रहे हैं. सिंस इट इज़ नॉट इक्वल टू 0 and its only real root h of theta is not equal to 0, then we assume that phi of t will be equal to 1. So that is what I have written, which is equal to 1, right? So integration, this is nothing but phi of t equal to 1. When we have this integration over the whole range is equal to 1, then we say that this is nothing but the one of the property of the PDF. That is what I have written. The integral has a properties of PDF, and therefore we will denote this as the one of the PDF. Suppose it is denoted by g theta x, then g theta x will be equal to this, which can be regarded as the PDF also, because integration over the whole range of this particular function is equal to 1. So this can be regarded as the PDF, the property of PDF. Now if we choose h naught greater than 0 and denoting f H such that hypothesis that f theta is true PDF of x, and H star hypothesis that g theta is true PDF of x, right? ओरिजिनल हम लोगों का hypothesis था थीटा नॉट अगेंस्ट थीटा वन. अभी हम लोगों के पास जो hypothesis अभी मिल रहे हैं वो है H and H star. H indicate that hypothesis f theta is true PDF. H star indicates that hypothesis g theta is true PDF of x. So again, this is a problem of testing the problem of testing using the SPRT. Then SPRT for testing such type of hypotheses can be defined as follows. So again the same hypothesis लिखा हुआ है, but यहाँ पे अभी you can see that the ratio involves g theta upon xi, which is nothing but our alternative hypothesis, and in the denominator we have f theta, which is the PDF under h naught. So this is PDF under h1, this is PDF under h naught. So if this ratio lies between now b to the power h theta less than a to the power h theta, because h theta is the root of the equation, then we continue the sampling inspection. If this ratio is less than equal to this particular constant, then we terminate the sampling inspection by accepting the null hypothesis, whereas if this ratio is greater than equal to the constant, then we reject the null hypothesis and the process is terminated. Now let us compute this ratio. For that we will first calculate g theta x upon f theta x. We know what is meant by g theta x. F theta x is given to us. If we take a ratio, the resultant value comes out to be equal to f theta 1x upon f theta naught x whole to the power h of theta. Further we have assumed that h of theta is greater than 0, therefore SPRT can be rewritten or reduces to, अभी यहाँ पे मैंने रेशियो देखो क्या लिखा हुआ है, f theta 1x upon f theta naught x, and of course the constants will be known since we have assumed that h theta, which is a root which is greater than 0, therefore b less than equal to this ratio less than a. Similarly, if this ratio is less than equal to b, we accept the null hypothesis. If this ratio is greater than equal to a, we reject the null hypothesis. Now just look at the SPRT. This is the SPRT, which is original SPRT. So even though we were testing the hypothesis H against S star, the SPRT that has been generated or is constructed is similar to the hypothesis of testing H0 against H1. हम लोगों ने स्टार्ट किया था hypothesis H0 against H1 से स्टार्ट करते हुए, then we reach a stage जहाँ पे हम लोगों का hypothesis हो गया था H against H star. but अभी जब हम लोगों ने SPRT कंस्ट्रक्ट किया फॉर टेस्टिंग H against H star, जो SPRT हमें मिल रही है वो SPRT पहला जो ओरिजिनल प्रॉब्लम है दैट इज H0 अगेंस्ट H1 के समान है, एंड देयरफॉर ऑन द बेसिस ऑफ दैट वी कैन राइट inequality 4, 5, 6. That means I am talking about these inequalities 4, 5, 6. As I said, they are similar to our original SPRT. Inequality 4, 5, 6 is identified with those which defines SPRT for H0 against H1 when the constant A and B are used. It is thus seen that SPRT for testing H0 against H1 leads to the acceptance or rejection of H0 according as the SPRT H against S star. That means both the SPRT are similar, right? It follows therefore that the probability of accepting H0 in using former case, that means the original problem when theta is the true value of the parameter, is same as probability of accepting H in latter case when f theta is true PDF of x. So जब हम लोग थीटा को टेस्ट कर रहे थे तो जो SPRT आ रही थी वही SPRT हम लोग एफ थीटा को टेस्ट करते वक्त यूज़ कर सकते हैं. That means both the SPRTs are equivalent. So let us now denote alpha dash as the probability that the latter मतलब H and H star वाली टेस्ट की बात कर रहा हूँ, let alpha star denote the probability that latter test will lead to the rejection of H when H is true value of true hypothesis, and beta dash be the probability that it will lead to the acceptance of H when H star is true. So these are the two errors, alpha dash and beta dash, when we are testing H against H star. Therefore, in the earlier case जो हम लोगों ने inequalities लिया था, if we apply the same inequalities, then we will have beta upon 1 minus alpha less than equal to b and 1 minus beta upon alpha greater than equal to ये जो दोनों inequalities है, they are the inequalities when we were testing h naught against h1. As I said, the same SPRT can be used for testing h and h star. Therefore अभी मैं inequalities जो लिख रहा हूँ वो है in terms of beta dash. So beta dash upon 1 minus alpha dash will be then less than equal to b to the power h theta, and 1 minus beta dash upon alpha dash greater than equal to a of h theta, right? So ये हो गया constants a and b in the case of h and h star. Again we are going to consider the same thing. Excess of that ratio over the boundaries of A and B at the termination of the experiment is negligible. Negligible मतलब जहाँ हम लोग hypothesis या sequential testing हम लोग terminate करने वाले, that means when we are going to accept the hypothesis or reject the hypothesis, उस case में that difference is very negligible. And if the difference is very negligible, we have seen we can replace these inequalities by the equality sign. Then the equality sign holds in an approximate sense, and therefore we have, instead of equal to greater than equal to, मैंने यहाँ पे approximate equal to लिखा हुआ है. So a to the power h theta is approximately equal to 1 minus beta dash upon alpha dash, implies that alpha dash into a to the power h theta will be equal to 1 minus beta dash. Similarly second जो inequality थी उसको अगर मैं यूज़ करता हूँ, then this is the equation I will get, beta dash which is equal to b to the power h theta into 1 minus alpha dash, so denoted by equation 11. So अगर equation 10 की मैं बात करता हूँ, then alpha dash into a to the power h theta equal to 1 minus, अभी beta dash आ रहा है, so using equation 11 I can write down that value as b to the power h theta into 1 minus alpha dash. And if I solve this now equation, then alpha dash approximately comes out to be equal to this particular function. But we know that what is meant by alpha dash. Alpha dash is nothing but probability that rejecting the hypothesis when it is true. That is nothing but probability of type 1 error, which is equal to then 1 minus probability that accepting the hypothesis when it is true. In other words, we know that accepting the hypothesis when it is true is nothing but L of theta. Therefore we will have 1 minus L of theta. Therefore L of theta, which is equal to 1 minus alpha dash, which is approximately equal to 1 minus alpha dash की वैल्यू हम लोगों को अभी मिली थी. I have put that value, and if I solve this, then I will get L of theta equal to this function, which is nothing but the OC function of SPRT, right? So OC function, as far as the SPRT is concerned, will be equal to a to the power h theta minus 1 upon a to the power h theta minus b to the power h of theta. H of theta, please remember that, is nothing but the root of that particular equation, right? जो phi of t वाला equation हम लोगों ने यूज़ किया था, उसका root मतलब h of theta होता है. So this is basically the OC function of SPRT.